Hello everyone, welcome to our pre-calculus class. This is our lesson 14 and this is just a continuation from our last class which is related to establishing the identities related to trigonometry of course. So the topics are pretty much same. We will try to establish identities here in this lesson also. One application maths also added from the similar topic. These are the basic things that we already discussed also, like the difference between identity and the conditional. They are important always. As usual, the trigonometric identities. These are the very important thing actually that we will always need them. So this is one math that there are actually four maths here in our book from the loan. So let's try to solve one math from here. This one is so if we try to solve it, there are some rule for we have to prove that this side equals to that side. There are some rule in logarithm, that rule tells us this ln a plus b. For ln a plus b, this actually becomes ln ab. So it is ln, we can write ln 1 plus cos theta then into a plus ab. Ab means a into b, then 1 minus cos theta. We are keeping the modulus sign here so that we do not have to do anything extra for that modulus sign. So everything is within the ln. You can give a bracket here also if you want. You can give a bracket here, but that's not exactly necessary here because there is nothing extra going on inside. So ln, but bracket sometimes looks better for doing the math. Then we can multiply them, and from our multiplication, as you can see, this is 1 plus cos, this is 1 minus cos. Basically, a plus b into a minus b formula we can use, which will give us a minus b whole square, a square minus b square, cos square theta. So this is actually this is actually coming from uh, a plus b into a minus b, which means a square minus b square. So 1 square equals to 1. That's why we have to keep it as it is. Then this is 1 minus cos square theta. This means actually sin square theta. So we can write sin square theta here. Sin square theta here. And as usual, modulus sign also we will keep. I think now you can see the solution actually. Now the solution is visible because this square actually power actually comes in the front for logarithm. And so this will become ln 2 ln then sin theta. Sin theta. So this way we can establish it. This way we can establish it. Logarithm, ln and log, both of them actually. Ln is actually special form, as you know. So they all the formula of logarithm you can use here. Uh, so that's the basic concept why we can use all the formula for logarithm here. The reason is this is just ln is just a special form of log, as you know. Log e base means ln. So we can use it. We can use all the formula that we can use for log. We can use all of them here also. So this is how pretty much simple when you know the rules. So there are a few more maths actually here related to logarithm. Let me show you that. Here. As you can see, 95, 90, 96, 97, 98, all of them are related to logarithm. So yeah, this math. Now let's try to solve one math from our real life application math. So this is optical measurement. Optical methods of measurement often rely on interference of two light waves if two light waves identical except for a phase lag are mixed together. The resulting intensity or irradiance is given by this equals to this, whatever it is. This is something, so which we will have to simplify, show that this is equivalent to this. So this given thing will be simplified to this. This is what we have to do. Yeah. So like what is the application part here. Then the application part in this math is, from a scientific method we have got this from a scientific from a scientific from a scientific experiment or something. They developed this kind of mathematical model. But later, if you know that we can simplify this to something like this, then actually this is easier. This form is easier. This form is easier. And most of the time in the scientific process, or even not in the science, in our real life also, sometimes you get from the data, from the real life situation, you will get most of the time complicated mathematical thing. Then if you can somehow convert it to some equivalent easier thing, then it is easy for us to do the further calculations. So we need this kind of thing in our daily life also. So let's try to simplify this thing and try to see if we can bring this thing. This is cosec theta minus 1. This is this. So if we try to simplify it, actually there is no straightforward thing here other than doing a couple of lines. So 4a square cosec theta minus 1. So let's write the formula here. Cosec theta means 1 by sine. Then minus 1. Then this also will convert. We will convert this also. Actually, this video will be a little bit short video, because we will be discussing these two maths. Then other maths are just for practice. So that you all can we can do the maths during the we can practice the math during the class time. You also can do the other maths, give it a try. Okay, that kind of thing. So we have just written the formula here, like sec theta equal to 1 by cos theta, tan theta equals to sin theta by cos theta. And from this side also, this thing also, we can make the formula, but we can keep it for one more line, or we can make the formula. Both is good. Both is good. But if we write it, actually there is no, let's write it. There is no certain immediate application of this thing now. We will need them after a while. So sec theta equals to 1 by cos theta. We can write it in the first line also, no problem. Then we have to just carry that. Now see, this is 1 by sin theta minus 1. So if we just simplify it, it will become 1 minus sin theta. And let me write this thing this way, if you understand. See, so see, this downside here is sin theta for sure. We are just doing this part here, and this is 1 minus, let's write everything. 1 minus sin theta. Then this part, if we do the LCM, it becomes cos theta. Then you see, both thing, our denominator is same, so we can just keep it. This becomes 1 plus sin theta. Actually, I try to skip this line and then do both of them in one line, but it's fine. So see, this we just have done with the numerator. We have to do something in the denominator also. Denominator is we can keep things as it is, so we can write here sin theta cos theta. We did not write that thing here. Then basically this sin theta cos theta will go up and it will come here, and it will be cancelled out from these two terms. If I do that, I think you will understand it. So let's do it in this line. I think all of you will understand this thing. This sin theta, since this is 1 divided by sin theta, 1 divided by cos theta, basically it will go up. It will be into here. It will be into here, multiplication here. So this thing, this 1 divided by sin theta, this thing, we do not have to write it here. Just write it here. This sin theta will go up. So basically it will become sin theta divided by 1. Sin theta divided by 1 into this cos theta, it will become cos theta divided by 1. If it is division form, so if you write it in the multiplication form, so they will get reversed. And you see, this is multiplication, this is multiplication, this is also multiplication. So we have the freedom to do one thing, that is cancellation if possible. So see, this one and this one we can do cancellation, this one and this one we can do cancellation. So we only have now, let's carry this 4a squared. So now we only have 1 minus sine theta, 1 plus sine theta, and now we can easily use the formula 1 minus sine theta, 1 minus sine 1 minus sine theta, 1 plus sine theta. That means 1 minus sine square theta. So we can write 1 minus sine square theta, and 1 minus sine square theta equals to cos square theta. Cos square theta. Cos square theta. And all of them actually we can write inside the bracket for I square. If we write 2a then cos theta whole squared, cos theta whole squared, then we will have all of them here. So you see, this thing and this thing is same. So this is 4 means 2 square, so 2 square means 4, then a square within the bracket, a within the bracket whole square, so it goes there. So basically this is the same thing as this and both of them. So what is, once again, the main point here is, from some complicated thing actually we developed a very simple thing here, and that is this kind of thing, this kind of operation is very useful for complicated scientific work, complicated economics, business related thing. You have some complicated thing and you simplify it to some functional or easily handleable thing, easily functional thing or workable thing, or understandable. This is quite easily understandable. Only one angle is related. Only one trigonometric thing is related. So basically, we can do the calculation very easily here. So this is how it helps. And then this is the guideline for establishing the identities. As you know, it is almost preferable to start with the side containing the more complicated expression, rewrite the sum or difference quotient as a single quotient. Then sometimes rewriting one side in terms of the sine and cosine functions only will help. So see, this is why for most of the math, sine and cosine function actually helps us to work with everything very easily. Always keep your goal in mind. This is very important thing. Always keep your goal in mind for solving the mathematics. It means that look at the right hand side so that you can solve it easily, and so that you know where you want to go, because there is always a multiple way of doing the one math, plus multiple direction you can go, many direction you can expand the problems. So it depends on in which way we should go. It will be given by the right hand side. So that's why we have to keep our goal in mind. This kind of maths we will try to practice couple of them from this in our class, and you can try some maths from here just for checking if you can do. And there are more maths related to sine and cos, so we'll try to solve few more from here. And then, so these are the maths that I thought if you can give a try just for your practice if you want. In any case, we'll be solving the maths during our class time. So that's all for today, and thank you very much. See you all in the class. Bye bye.